saying that you can see that my publication profile. So that's as I said, energy and greenhouse impact of mining and mineral processing. There are, if I go by year, maybe if I move that, and you can see some of the updates here. So for example, recovery of materials, there are electronic waste recycling, greenhouse gas assessment of biomass integrated steel making. That's one of the that's Mahash's paper obviously. But there are other papers on biomass in steel making, decarbonization of power industry to some extent, but more on the evaluation side. You can see wave power, working with not only myself, so I've got collaborators all around the world essentially. So in Europe, UK, US, Korea, in India, obviously lots of colleagues. So you will see some of them are, particularly one paper I was trying to see. A lot of people you will see in hydrogen. Actually, I know we have got sessions on flame electrolyzer, solid oxide electrolyzer. So I told Abash to download one of the book chapter we wrote. That's quite a good overview of which under this, but various hydrogen technologies and issues, challenges, etc. So if you hydrogen transportation and distribution, various aspects of floating solar plant. So if you look at the decarbonization techniques people are talking about, mostly renewable energy. So a lot of our work, using solar plant to run a small health center, for example, floating solar 50 megawatts, 100 megawatt, that sort of system. What's the cost? What's the CO2 footprint? This sort of area, basically my kind of, you can see techno-economic and mostly techno-economic LC of various technologies. You can see particle access with different types of wind turbines. So some of the work also going on. So this paper I was talking about, electrolyzer technology for hydrogen economy. So if you look at that one. So Abash, this paper, electrolyzer technology for hydrogen economy, please download that chapter and make sure everyone gets that one. I think that's what I was going to, maybe that is other paper, because we have so many, I myself lose track. So one of the paper I can remember we did on one of my PhD student did that life cycle assessment and technical evaluation of carbon capture technology attached to the large power plant in Australia. So that's our Blackpool thermal power plant. And if you attach CCS technology, what's the consequences of that? So that's if you are more interested, I can go and come. I just I have a lot of information anyway. So all of life emission from coal seam gas to liquid natural gas, and if you use that natural gas to power, what sort of consequences of that will be possible? So that's one of our big projects I had at some stage. This one is I'm talking about closing the sulfur loop. So CSR has a technology to capture CO2. So that's the so we call it co-cap CO2. So Harti Garg, one of the Indian student now, she's doing very well. Actually she's graduated and 7 years of experience. I think she works for ABB now. Several other organizations she works for. ABB and ABB Power, different types of power company, power plant equipment. She sort of manages that. So I don't know if some reason looks like internet is not up to the speed, but but you can, as I said, if Google, go to the Google Scholar, write my name, and if you find out any paper is most interesting you want to go to read, let me know. We can go. So I think that's just quickly. So I think let's move on to this topic. So I'm by the way, Akash, please give that feedback form. So I know they have other feedbacks and other responses, but my one is kind of I would like to know how we are going and how you are feeling, etc. So that's about course. And so as I said, my expertise is hydrogen and LCA technical mix. A bit of broad here and there. I have worked with in. I have a bit of broad understanding about power plants and kind of steel plants and things like that because of the working with other colleagues, but I'm not necessarily have that expertise. So still decarbonization roadmap to net zero by 2070. I know there is this same topic someone else from Terry is speaking of. So I'm not sure what Terry will cover. I'm coming from, I know India has done, by the way, just this morning I found that India has got hydrogen certification scheme. So we talked about yesterday hydrogen CO2. Do you know what's the certification level in India? 2 kilogram CO2 per kilogram hydrogen. 2 kilograms CO2 per kilogram. Below, then we certified. Number one. But problem is
yesterday we are seeing 4 kg.
4 kg, so it looks like, yeah, so they have been more stringent. But on the other hand, sometimes it's hard to, even government organization, if I ask them, what do you mean by that too? Is that yearly average? I think they have said yearly average over a year. At least that's a good start. But that too, does that include direct CO2? Does that include indirect CO2? Does that include, say, electrolyzer, solar plant, infrastructure, etc.? It's not very clear sometimes. But I hope I have not gone to the whole document. I've got seen that I think Ministry of Environment or someone has got, and then they, what they call that, a unit they have got will check, verify, and things like that. I hope that they will go through the proper procedure. But often I find the government departments, because they don't have many technical people, I believe, hopefully they are there, and that clarity is there, is that direct CO2 emission or CO2 emission, because ideally in most cases renewable CO2, direct CO2 almost nothing, negligible, nothing, because you are not burning anything in. So hydrogen should be the similar report, but I don't know, some reason they have picked, I know in Australia we had 0.65, so I believe that's the direct component of CO2. So there's a debate going on, should we say indirect, if it is indirect then maybe 4.5 and that sort of thing. So, but matter of discussion. So but I hope that they will nail it down and get the clarity to the industry, whoever is going to invest in hydrogen industry, so they know that one. So that steel decarbonization, I know Ministry of Steel has one document, big document. Are you familiar with Ministry of Steel document? In India, they have got that net zero for steel industry. So I'm not going to cover that aspect, rather than I'm going to say what we see from outside, whether that is realistic, whether that is practical, whether that is achievable, and maybe I'm not right. My observation or our judgment may not be 100% right, and I'm using some other documents, what people have observed in that circumstance, so that situation, and also maybe I will say what's happening in Australia, so you can get a better feel for it. So that's what I'm going to talk about. So far, okay? All good? Any question before I start? No? All right, good. So I think that's what we are talking about. So that's training the steel sector in India roadmap and action plan. I think that's what I was referring to. I'm not sure whether that has been updated. So that's Indian roadmap. Basically, I believe that very gentleman, whoever the speaker is, I don't know, whether that will be repeated or I don't know, whatever the content, but I'm coming from the outside as perspective. So the main is star rating, and then star rating came, I think, in December last year, something like that.
Yes.
For
the steel industry. Taxonomy of steel.
Taxonomy of
steel came last year.
Last year, isn't it? So and that some recommendations made here, but I think at the end of the day, cost is an important factor, and we often, I think, I'm not sure how that is taken into account. So I think that's how, and for the future, we can discuss a bit. I think I would like to get your feedback. What do you think that document about? What's the strength of that? What's the weaknesses? How do you as an industry probably influence the government to come up with a better plan? Or is it completely sealed, or you have no changes required or no improvement possible, or it is still flexible? That some sort of flexibility would be there. I think often you will see that one, that Indian CO2 footprint is high generally. So that's where I say, oh, they have already high, their star rating is a little bit, I would say, soft maybe.
Indian, not as Indian.
Is it?
So it is in starting phase.
Exactly, that's right. So I think at least somewhere you have to start. So same with LCA field. People say, oh, I want to know the carbon footprint, but there was a lot of rubbish data. They say that, oh, do not criticize like that, because we need to start somewhere.
In India, the really seal scenario comes around 21, after 21.
Right.
We came to know that there is a term called green steel in 2021, after the COVID era.
Right.
After that, some plans from the government came to Indian. Little bit stringent right now from the initial one.
Sure. So now actually there is a thing called green metal. Have you heard of that? Green metal. Actually we have got some allocation of green
We had
metal.
green gas.
Now green, everything green. I don't know how green is green. How do you define green? So that's why I said, what is your ECWW footprint or LCA footprint? Then genuinely you can claim green. So otherwise it's greenwashing, I would say. So I guess that that very important. That's why. So green another. I have recently learned called teal steel. Have you heard of that teal? T-E-A-L. Teal steel. I don't know. I think that's they're saying that blue hydrogen. Use blue hydrogen make steel, and that's a teal steel. Blue hydrogen. You know the definition of blue hydrogen. So you make hydrogen from fossil energy, but captures it. I think here, obviously, I sometimes I don't like color. I like the CO2. Actual, what is the intensity of CO2? That's what happens. So I think same with the hydrogen. You saw that one, gray hydrogen, blue. There are so many colors. All the what we call rainbow color, and you know what hydrogen. But it maybe people understand that, but it's not a confusion. I think what is the CO2? Tell me the CO2. That's what I think. Any question? I think behind some colleagues joined left, so we are going to talk about green steel roadmap to net zero by 2070. I think Indian government is 2070. Many governments 2050. You know that one, right? Yeah. So that many Western countries and others. So let's discuss a little bit more. So I think that's yes, you read from that document and as a you are familiar with that. So that's that 20 there's net zero. But we are starting now. I don't know 2040, 2024. Slowly. That's a roadmap. The roadmap means you know that one you need to what's your target? Target is here, and you do all sorts of things. So initially, what the big the task force obviously. So I heard one is Ministry of Steel in India, very active in that area. Another SRTIM, something like that. Any other organization? What's that organization called? Anyone know about that? What? Steel Research Technology Initiative.
There is a research organization, conglomerator for the.
Is that government organization or is that?
Partially, government has a stake in that.
And also industry
all the steel authority.
Major steel manufacturers.
Joint venture of all the.
It's called STRMI, something like that, isn't it? Yeah. So who is the head? Head is a government person or industry person?
They choose.
They choose. It's a kind of government initiative.
Government.
But bringing industry on board. It's more research or also
research.
Only research.
Research.
Only research.
Research and new practice.
So in that research, industry has a say or not?
The representatives are from the respective steel corporations.
So a steel company has got representation in that board to choose research topic, is it? Or something like that? And they also fund it or not?
I'm not aware.
So but anyway, that organization yes?
STRMI.
What's that called? Is that someone can
STRMI.
Steel
Technology Research Management Institute.
Research and Technologies. SRTM. Steel Research and Technology Institute of India.
So do they have a role in this kind of roadmap or not? Are they separate or?
Might be they might have consulted it in drafting.
Yeah. Okay. So that's my feeling is that they more research oriented, whereas
it is relatively new body.
New body. Yeah, that's right. 5 years maybe,
four
less
years.
than 3 to 5 years, something like that. Anyway, the head of that department visited Australia a couple of times. That's at least one gentleman I knew. I forgot his name, but and later who came and who runs, I don't know. Because COVID time, it was a bit of it's just before.
Their aim should be that I think 2017 at zero only, because it's a government body and government is planning for this achievement in 2070. So that body will also work.
Have some input, some intellectual input.
Yes, in this direction only.
Yeah. So that's maybe doing some research and doing some kind of research-based knowledge, evidence, etc. But my feeling is that maybe they are working with IITs, NITs, and other labs and the steel industry to come up with a solution. Because at the end of the day, in Australia we call it a center for open research. So most of our research done under that CRC type arrangement, and that's very large. I would recommend you those who are steel industry explore. In Australia there is an organization called HIL CRC. So CRC means about say $100 million activity over say 7 years. Okay, and that is universities like CSRO, industries, everyone basically. And that PhD part of that HIL CRC. So I recommend why I'm saying please look at HIL CRC. So it's HIL stands for I think heavy industry, low carbon transition, basically hydrogen application in heavy industry. And that is steel, aluminum, cement, I don't know type activities because Australia has got lots of them also. So, but there are lots of projects around because of PHP and maybe I'm not sure Blue may be involved. So, more application of hydrogen in steel industry or heavy industry. What's the consequence? What's the challenges? What's the opportunities? It's about $100 million and plus more activity. I think that is delivered by University of Adelaide. Not delivered. I think one of the main key participants. CSR is a partner. Lots of my colleagues do a lot of technical economic and life cycle assessment of each of these scenarios. So I think it's a fee-based organization. So if you get actual IP, you need to get in, you need to pay fee. But what I recommend you, have a look at that. Some of the things already publicly available. They release. If it fits with your need, you may at least explore that one. And then if it is really something interesting, then you can approach them and they sometimes provide. A lot of they have found a lot of PhD students and they also publish. So it's not necessarily, but IP is only to that group essentially. So Hill CRC is the I think all the world. If you look at steel research. There are a few bodies I know in the US, in Japan, etc. Some of the companies have their own, like Tata. I know Tata has got a lot of work, but this Hill CRC is one of the largest funding and research body around the hydrogen application in every industry, including steel industry. So it's not power industry, but mostly hydrogen, mostly heavy industry, I would say, where we call it hardcore heavy industry. So they don't have many choices to decarbonize. Maybe hydrogen is one of them, so that's why seriously they have invested a lot of money. And those topics of research is selected by the industry, and researchers will do that one. So very good arrangement in a sense. Like, so you can tell me that, okay, this is our problem, we want to do research, and the researcher can do that one. So I think that they had a framework, R&D, R&D. So what does that mean? Research, development, and demonstration. So like more pilot plants, demonstration plants, like our Acharya sir has got. So that one, and then establish dedicated funds. SSI, I'm not sure. SSI means steel something, maybe government
Steel
initiative.
sector investment.
That's right. Some sort of government initiative maybe. Support CCUS policy development, and then increasing. I don't know.
What is double E?
Sorry.
What is double E? Increasing double E?
I don't know. Energy efficiency.
Energy.
Efficiency. So lots of acronyms. It's hard to decide for, but generally they are decarbonization, energy efficiency, renewable energy. So when you say what are the technologies? Not a lot of choices to be honest. I mean, only choice either to switch energy, because we know that on any LCA, the contribution from the either thermal energy or electrical energy will be the major contributor of CO2. And if you want to decarbonize, switch energy. But the problem is that can anyone do that one? That's the question. And just incidentally, I got that news in the morning that in Australia we have got, as I said, solar residential, which I have got 4 million residential, it's a huge amount of energy. Then we have got utility solar, so it's a 20 megawatt plus, 50 megawatt, 100 megawatt. So looks like next 2 years, all these solar plants, 2/3 of the time or 2/3 of the electricity generated cannot be used because we have got excess. Grid will be jammed. So basically dump it. So I don't know what will they say. Okay, let's make more transmission lines, but that's one way. But you need to have investment. So my feeling is that hydrogen story comes very quickly. Somebody will say, "Oh, this is free energy. I can make free hydrogen," and then once something starts, maybe that will accelerate other things. So
hydrogen plants.
Yeah, kind of situational, isn't it? Because if I say I've got 2/3 of the time, I have energy, solar electricity, I cannot give it to the grid. If somebody can take it and use it, it's a good proposition, isn't it?
It should be utilized.
Should be utilized. So what you have to invest, if someone take it, someone has to invest on a hydrogen plant, electrolyzer plant, etc. So once you convert to chemical, you can do something with that. So that just is, so any countries, it isn't a problem that too much renewables, as you said that Germany, they had, isn't it Europe, the 7-day shutdown or what they call 7-day blackout or something that happened because of too much solar and grid cannot cope with. So that's, you need to have a lot of modification and things like that. So sometimes solar, if we produce too much, what to do with that? So you need to manage that expectation. But it depends on the country. For example, if you have got a big plant, something can take that additional electricity, then that's fine. You can switch to that. So that's right. So increase pellet and scrap utilization. So India has own scrap market, right? You are or also you import scrap, I believe. Is that correct? Some, and that's mainly AFP, right? Goes to the electric arc furnace. Is scrap quality, is that a problem or is that a
Scrap quality is a problem.
Sizing and quality both.
Segregation also problems.
So that's why I'm so going today afternoon. I think I'll finish a little bit early and then go to the IS and Dhanbad Indian School of Mines. So Dr. Vishnu Teza, he's got a student Sonath Mukherjee. So he's a PhD student. So we funded him. So his job will go to various steel plants, take the scrap samples and then classify them based on quality, and then they will make using that scrap steel and take the sample. They will analyze the sample and see what's the how the scrap quality impacts or affects the quality of steel. So it's a, but apparently that sort of information is not much there around. I told them, can you review it and is there any good work already or industry's practice, etc. They said no, not much. So that it was that topic. So transition to DRI and that's happening already. India is booming. I think India and Iran, two countries are most DRI producers as far as I know, right? India and Iran. Implementation of short and medium term R&D projects. So R&D is the key part of because these are the new areas and a lot of people do not know what happened. So R&D, I think we cannot ignore it, unfortunately. But on the other hand, R&D, what type of R&D? Academic R&D or just more applied R&D? So it has to be more practical and applied. Pilot on green hydrogen, biochar and CCUS. My feeling is these are the three technologies, and you know that one, right? Your Kanpur plant also similar kind of energy efficiency, then renewable energy penetration, then carbon capture, then hydrogen. Long way. Hydrogen is long way.
Hydrogen is long way. We will be planning for CCUS.
CCUS. So, but do you know how much cost to?
No, I think it's in a very nascent state.
So you have not done that one. So I can tell you roughly. Best technology at the moment is about say $100 to $150 per ton of carbon.
So is it only carbon capture or utilization?
CCUS.
CCUS, so utilization
For
component.
utilization storage part also. So for the utilization you need a hydrogen, I guess. Where are you going to sell the synthetic
No,
products?
it's just in a nascent stage.
Pilot.
The tenders are need to be given out. So it's in a planning stage right now. So
उस पे कह रहे हैं वो राम चरण में आता है किस पर CCUS आपके यहाँ किसमें लग रहा है गैस में
हाँ.
because
So what was the discussion? Can
actually I'm from Kokovan which is one of the part of the steel industry and it's from I think blast furnace.
yeah.
So one of the project was planned according to the ministry they sent someone. The planning stage was being started but the rules are very stringent. Right now we are getting the licenses. So the project has been halted. I think it was around converting the CO2 to ethanol and something.
Methanol or some other chemicals.
But the guy claimed that he can also produce clay threads. That's gas hydrates. That's not possible with this technology because it requires high pressure and a low temperature.
Yeah.
Gas hydrates. I think the research is in Singapore, NES. I don't remember the name of the guy. I think you may be knowing him.
Right. Yeah. So I think methanation or any other chemical you make, I was in methanol plant as I said last week, and CEO get late and he said that the plant is not equipped with taking a small amount blending is okay, but if you purely hydrogen and CO2 to make methanol, that's another kind of plant configuration required. So some modification required. So we need to be obviously in capex, etc. So what I was going to say that if you capture CO2 and store, so our last paper as mentioned that we have to be about $120 per ton or something like that. So sorry, part of CO2 captured, processed, etc. So then enriched. I think if you say at least $100, put the ballpark figure. So if you say 1 megawatt electricity produced from coal-fired power plant, we know 1 ton of CO2. Okay. So if Colin say that one, that was what was the price like? $100 per megawatt cost, isn't it?
$80 to $100.
So $200 we add another $80 to $100. Are you prepared? Anyone buying that is prepared for $200 per megawatt? That's what we're talking about. $200 megawatt possible, then carbon capture possible now. It might be coming down the cost down the track. So that's another proposition or another situation we have to keep an eye. a lot of, because amines are generally used, as you know, to capture CO2, and they have to be regenerated, and they are pretty costly. So that, and you need to have a plant, you need to have, as I said, the efficiency goes down. And yesterday we were talking about another thing, supercritical technology, right? So that's high temperature, high pressure. So what I'm not in that field, as I said. I mean, my experience is not power system engineering or anything like that. But what I came to know that the materials required to this kind of pressure and temperature, you can go up and make power plants maybe 70% efficient, but you need that kind of material, which will be very, very expensive, and maybe they don't exist yet. So that's R&D and things like that. So my understanding from the discussion with the experts, they say that it's more material challenge than running the power plant under supercritical or kind of condition. That's more challenging. So, but we have to see and wait, and technologies changes and come. So it's not end of the day, I see that. So that looks like green hydrogen, biosars, CCUS, and that's why hydrogen story is very, very integral part of any decarbonization. That's where our expertise comes
So
from.
why biochar is considered carbon neutral?
Why biochar? Biochar, if you say food, it depends on what is the harvesting rotation. Maybe say 10 years, 20 years, 30 years, 30 years. So after 30 years, you cut the plant, because plant absorbs CO2 from the atmosphere, right? So now, so you plant today, you absorb CO2, because CO2 plant is, as I said, CO2 plus water, you have carbohydrate, and you 30 years to grow, you cut it, you make char, and when you make biochar or charcoal, essentially you put a kiln, right, in a retort or kiln, they're very energy neutral kind of, because it
Why it is considered in calculation as
Green.
carbon neutral? Yeah.
So to make biochar, you spend a lot of energy. You need to have net energy, but once you cut it, you replant it.
So is the case with other trees also. We can also do the same. So why only
Biochar.
bamboo biochar is considered?
Oh, I see. So because bamboo maybe, I'm not sure about that, but bamboo may grow very fast. That's why they're targeting bamboo. But any biomass, biochar is any biomass to transform to carbon. That's biochar essentially, my definition. And then biochar, it could be bamboo biochar, it could be wood biochar, it could be sawdust, it could be agricultural residue. But ultimately, they have to replant and reobserve that carbon they kind of emit over the period of time. So it's a kind of cap. Because what we do LCA, you know that time frame. We call it, when I chose method, I'm not sure I showed you that recipe endpoint H or recipe midpoint H. So there are three things, H, I, and what's the other one I forgot? Hierarchical, individualistic, and egalitarian. So three IPCC, again, that's what methodology guidelines question comes in. So methane, if or CO2, if it stays in the atmosphere for 20 years, that's one kind of impact. If it's 100 years, that's another kind of impact. If it is 500 years, another kind of impact. Generally, we use recipe, H is hierarchical, that means midpoint, 100 year time frame. So within 100 years, if you plant and grow and recycle, that becomes carbon neutral. That's the definition. Does that make sense, or does that consider it?
Considering the case of bamboo, I wanted to ask.
Bamboo is how long? I don't know what's the harvesting time. Usually,
Because they don't consider the seed.
Oh, those are
like
2 to 3 years.
2 to 3 years. 2 to 3 years carbon phase is like a harvesting any agricultural crop. So that's why it's a cycling. You are carbon cycling through the plant, through the trees. So I'll probably I have a lecture on the. Is that after this one? Maybe I don't remember that there's a lecture on biomass in steel industry. That's maybe I will say why it is carbon neutral. Okay.
Dr. Nashad,
Yes.
actually, I want to ask, when you're doing the LCA calculation, you are keeping it, I mean, for the CCUS, if you're doing, you are mentioning the what kind of technology you're using. That you have mentioned that we are using amines and other kind of. If we change the technology, will the result change?
Yeah, with some technologies are more efficient, some technologies are less, and some technologies can recycle product and things like regeneration. Cost is an issue also, and within the amines there are varieties of amines.
Because I read a paper in I think 5 to 6 years because Vedanta is doing something with the carbon dioxide and copper-based catalyst. That is high temperature and pressure process, but it was converting into methane somehow. So will that give a lower carbon footprint than this one?
Yeah, I'm not sure about that particular process, but for example, our process, we looked at each how many are prepared, how they manufactured, how long they will stay in the reactor, how much CO2 will be absorbed, I mean, everything is deep. So that's the way ours, because CSR has a technology, this technology, and we licensed to quite, we had a big pilot plant, ran over, even demo plant, we ran over several years. So that's our technology. And our technology is now quite mature, I would say. And we have, because we tested various types of amine, and one of the amine now is very efficient and very cheap cost and really regenerate very quickly. But I'm not in that area. It's a chemist group, they develop the technology. They say, what is the cost effectiveness of that, what is the CO2 footprint of that, and you have to go case by case. And not only that, that's another important point, that specific situation, specific power plant, these information are very important because some power plants run differently. So that's what we did for Australia. Maybe some plus minus you can take, but essentially it has to be generic, it has to be specific to the system.
Previously you said that the Aspen hydroxide which can be coupled with this LCA also.
Aspen, we use Aspen modeling also, but also we have a lot of test data. So Aspen modeling is predictive, but you have to have
means you have to get a real time data to validate.
real-time data because we have a big pilot plant.
Maybe in the variation of 10% we can validate it.
It sometimes, it's a bit of tricky because Aspen is very much predictive. The reaction doesn't happen sometimes. So many things goes different ways. So that agreement is very important. So sometimes vary quite a bit. Yeah, that's right. So this is all, you have to all tools. It's all about infrastructure, people, expert, and doing together with the real data. So that's a very key part of that every decision. So implementing long-term R&D projects. So that's I said. Professor Shukla here. So R&D you cannot ignore. That's commercial green hydrogen steel making. I believe CCUS, and they are saying 2047, and that way. Kind of retiring high emission capacity means blast furnace retirement. Does that mean by that, right? So
Blast furnace
I don't know, but some people predict there will be no blast furnace in the world. But
actually, already the work is being done. Like POSCO is supposed to phase out their blast furnaces by 2047.
But sometimes they make those kind of
Yes,
decisions.
but that is right now on paper. I don't know about
Yes,
but
right.
actually
So it's a sweeping statement. Yeah, Professor.
India,
Yes, sir.
look at the recent developments or recent capacity enhancement by various steel plants, we find that it is a much bigger size of the blast furnaces are being installed.
Recently.
Yes.
They are supposed
So that will run at least 40 years.
At least 50 years.
40 is
At least 50 years.
At least 40, 50 years they will run.
So whatever 2070 is an ambitious target.
So
Definitely it's going to be cost competitiveness and to be competitive.
Developing countries like ours cannot afford to obsolete this kind of technology in a shorter period.
So my feeling is that maybe slow modifications will take place.
Yes, like hydrogen injection in blast furnace,
Other,
reducing the fuel
etc.
rate.
So, but getting out of that, which is the same with Evergosh ammonia technology. If someone can't, so much work has been done, solution yet. It's 100-year-old, more than 100-year-old technology, beautiful technology. Now, no choices. We are developing one. There are 2-3 technologies people are working on, and we are one of them, and quite advanced ammonia technology. Because what is Evergosh technology takes, it's like blast furnace. You can have a big facility, 1 million ton per year ammonia production. If you go below, maybe economy does not work. Our one is modular, 10,000, 20,000, 50,000 you can have. Because ammonia is required for the fertilizer, and farmers they don't need to carry all these materials around. Potentially maybe that's a possibility. But our technology is low pressure with membrane. So that's a different kind of, there are a couple of other groups working around the world. So I know, so that roadmap for net zero transition in India, any country is not easy task. It's quite a difficult task. But we have to start somewhere. We have to at least things that people are talking about. There is no such thing as a star rating before, at least now that can about. So I think
there's one thing that with the existing blast furnaces that are supposed to run for longer duration, they can be revamped with the method of accepting the fuels which does not contain carbon, like how they get maximum amount of biochar or hydrogen or any other alternative source of fuel like coke required to be done so that their food rate should be brought down actually. So basically on the decarbonization front, in India particularly, apart from looking for tangentially for technologies which could become the future, we should also look into the intelligent approach to bring down the carbon emissions or the coal consumption in the blast process or for example natural gas in the existing nutrient process as well.
So the works are being done like the new furnaces that are being designed right now. There are provisions for injecting synthetic gases
Yes.
in the stack region. That is, we inject CO and H2. So that will promote the indirect reduction and reduce the direct reduction, thus reducing my fuel rate. Once the fuel rate decreases, my carbon emission reduces. So presently that technology is being worked on. Maybe in the future more.
And another thing is, particularly in Indian context, we are having huge reserve of non-coking coal.
Yes.
And that can be utilized for generation of the syngas by gasification, and that will be, I think, more and more investigations followed by large scale syngas production facilities should be created so that they can supplement dairy making units subsequently and electric arc furnace. So obviously by that route also our carbon emissions will be brought down.
So there are lots of things within plant is possible to do.
Yes.
Another thing, blast furnace gas, can they be separated into CO and hydrogen through some separation process? You can. So then it's not, maybe there is no technology. I know there are electrochemical system people are working on that you can separate gases and then hydrogen can go to hydrogen application, CO can go to further reaction. So instead of sending to the atmosphere, at least you can reduce. So that's, I will say, what the message is that there will be a number of innovations when people are forced to do that. They will make using existing facilities or infrastructure like blast furnace. But that's another thing. It's not only India. It is third largest steel producer globally, isn't it? Second. Or second largest now. So highest in China and second is India. So in many places, you know that there are other steel producing nations also that blast furnace probably they will be retired. Then they will move into other areas. But it's a growing. India has got different scenario because they are growing a large target of steel making will be starting very near future because they need steel. So then maybe existing technology is a way to go, but with some modification as much as you can. That's my view. So I was, as I said, that was in December maybe last year. I was in India. I saw that news, and usually I read newspaper and I saw that. Looks like quite interesting. This is on airport, and yeah. So that the star rating you see that one 5-star, intensity lower than 1.6 ton CO2 per ton of finished steel. So now 1.6. Do you know what is global average? 1.9, something like that, or 1.8, something we say. So that 4-star, you know, 1 point, and then 3-star, 2, and below 2.2, no star, isn't it? It's a kind of what they call gray steel or whatever the steel is that. That's a conventional steel essentially. So now, do you think this, if you say produce 5-star steel, what's the benefit? What's the advantage we get? It will be preferred for government buildings maybe or something like that.
Until unless premium cost will be given.
Going up?
Until unless.
I can see
India
how
future-
somebody prepared to pay,
Yes.
or somebody prepared to take that steel in large quantity. So that's what they're saying, isn't it? Some sort of government will make.
In near future, I think for exporting this kind,
One is export,
this
one is
kind of
export.
this kind of rating would be mandatory.
Yeah, so one is export, that's, I don't know how much you export, but even internal use for say government big projects, if they say that we'll pay extra or we'll take your mandatory, you have to supply 4-star or
Government
5-star
said, I think 1/3 steel they will procure after 2030 green steel.
they still have
After
like 5-star,
1/3
steel, something like
1/3
that. So is that in the industry, that's accepted by the industry or this is just government imposed and that's it?
Right now it's imposing.
Imposed.
Right now
So
it's
Not
imposing.
imposed, but
Immediate is like always.
but Tata Steel and JSW I think are already producing steel in the
Less
3-star
than-
category region right
Less
now.
than 1.6.
3-star.
3-star steel. Already they are producing between 2 to 2.8.
No, not maybe 2.2 right now, maybe at 2.3, 2.4, I don't know.
None of Indian companies are eligible for this
No,
target.
what is now? It is
We are
JSW.
not at all eligible. If you look at the
No, below 2.2?
below 2.0, you are not eligible for green.
No, no, that's what is it?
We are 2.5.
Oh, 2.5.
So your is 2.5.
2.5. So I think Tata Steel and JSW are far in a much better position
Okay,
to produce this kind of steel as compared to other PSUs.
I have got a question to you that if global average is 1.89, why India is 2.5? Because they are scrap based. Okay, so
They are using electric arc
no, they are
furnaces.
not. I mean, is that they are
US entirely scrap based.
Scrap
That's
based.
why. So it's a kind of skill deciding.
No blast furnace.
No
But
blast
still-
Blast furnace capacities is much lower in the
Okay, so because it's a mixed, like a reed composition of renewable and fossil, that's like that. I can understand now.
Iron
So-
ore also matter.
Yes.
Iron ore also matter.
Exactly. I think
It's actually
I'm coming to
small.
that point. My feeling is that iron ore quality has a bit of issue here. That's the and because electric arc furnace is 0.5 maybe something like that, isn't it? 0.5 ton per ton of steel. But again, electric arc furnace can be zero if it is renewable electricity. But with current situation, I think it's 0.5 my feeling. Yeah. So
Actually, my feeling is that as long as we are using the primary raw material for iron and steel production, it will be fine actually. But gradually, as the scrap, more and more scrap will be generated, I think the process will be successful.
Scrap is a situation called
that's right.
So as far as the outside domain are concerned, they are mainly using scrap-based technology.
Right.
So that is why their difference is low. Whereas for India, Brazil and China, actually it is still higher because they are.
I don't know if any other country has this kind of system. Anyone ever started it? Not yet. So at least something came about good. I highly appreciate that because it's a definition now. We know that some people say I have green steel. You know what is it? Put in the system and see whether you are green or not. I think that's a good thing, isn't it? There will be at least some clarity around that one. And I'm not sure any other country has that one. But anyway, so that I think I was in that time that saw that news. All right. So next, I think what is this one? So that's Switch Foundation, isn't it? Your organization. So I saw that you got very good document synthesizing. I think it is last year maybe, isn't it? Or this year? I can't even know. In 2025 actually you developed that. So you were talking about steel production in million ton. That's in India, I believe, right? 2021, 2030. So that this one is what is this component?
Coal-based technologies.
Isn't it? So that's coal. So looks like coal is coming down. Right? That's
How come in 2030 the green hydrogen part is that much?
exactly within 5 years. That's my point. How will
Which technology are we using?
maybe DRI?
It's a
You think DRI?
It's an assumption.
Is it realistic?
I don't know, but they have analyzed all information and some sort
Now
of
it's
prediction they made.
2025 and this is, we are almost negligible and by 2030 we are seeing.
Yeah, so my point is that the hydrogen component looks like very high and is it, yeah, maybe that sounds like DRI will go, take over and even it is taking over by 2030 for another 5 years, right? 2025 is a halfway, isn't it? It's July. So 4.5 years, so how much hydrogen do you
See,
anyone has got calculation?
in India the largest is JSW, third is SAIL. The two plants are here, and we are nothing.
No.
Right now we
So
are
if I
nothing.
put another 5 years, do you think possible?
Only Tata is the problem.
At least I know sale is not possible. And
Sale is
based on
impossible,
the
but
Not at all possible.
So,
Tata Steel है क्या?
so maybe it's unless we sustain.
Any technology you can see.
Look at the investments in this year.
इसका मतलब
Plus 50 कर लो, plus 50 कर लो ये। इधर 30 को 40 कर दो।
मैं 2030 तक मैं बेरोजगार हो सकता हूँ। इसका मतलब ये है।
एक बंद कर दो।
इनकम बंद हो जाएगा।
None of those investments focused on the not even a single unit.
Single unit.
So that's, you guys are better kind of, that's why I'm
We-
sort of brought in, I thought let's.
We are planning a new 4.1 MT plant to be commissioned in 2030. We are tendering. The training already
They
started.
want to start and there are no provisions
There are
for
no
DRI
provisions.
and nothing.
So that,
Time charge है ना?
what's the white one? Is other. Scrap.
हमारे बड़ी मुश्किल है कम time charge का।
And
Yes.
so green hydrogen and coal going down,
Both
what's the
are-
direction, what's the rate of natural gas? Natural gas doesn't change much. Is it seems like right?
Its availability is stagnant right now. यानी कि same.
So looks like a bit optimistic about hydrogen, which is I like hydrogen. I say that. So but
Maybe this gives a boost for forward-looking enthusiasm.
people like me, I guess. That's okay.
Add at least 15 years in the border.
So, at least people are thinking about and we look at you just better that where it should be and we can give it a check. So I think that's next slide. These are the recommendations and again Solution Foundation synthesize the roadmap and they think if you go one by one, value chain optimization and monitoring, carbon capture and utilization, renewable energy and hydrogen transition, sustainable alternatives, recycling and circular economy, innovation and collaboration. So I think that's a broad statement, but mainly optimization. I think what Professor Shukla mentioned. Within the plan, there are a lot to do, right? And still, it's not big, but at least you can invest and effort and make efficient. Second one, carbon capture and utilization. Definitely that has a big role to play. I believe that, but again, cost effectiveness. How we make it? Our Australian target by 2030, carbon capture should be $50 per ton. That's the target. At the moment, I said $100 parts. So you need to reduce by 5 times. And what technology, how you do that, that's the question.
Right now, first thing is we are focusing the power. Okay, the steel industry, the power we are using should be green. We are thinking in that way. It is a starting process. And right now, around 25%.
So, but in blast furnace, your power doesn't matter. If you power green is still
in the whole steel plant.
the whole steel plant. So if you switch to power, have you done calculation how much reduction possible? Just power, not coke.
Right now the target from the management is 25% power should be green, minimum.
And if you do that, what sort of steel, let's say 2.5 come down to
0.2 reduction is possible. Right now we are 2.9 around.
2.9.
So 2.7 we can reach by the green power.
Right.
So this is the first step
Yeah.
the management is thinking, because it is bit easy, because we are purchasing power from outside.
And
So we are asking our supplier to give us the green power.
now, do you think the power companies have the capacity to provide that amount
Right now
of
we are purchasing power from DVC. So currently 50% power is green, certified by DVC. Right now.
Okay, so that means they have renewable power.
They are purchasing from
Another body,
other bodies.
invested-
Some installation process are also
So since
they are taking them.
things are moving in right direction to that extent.
The first process is power.
Power.
For the
So
steel
decarbonize
authority,
power.
at least.
Your suggestion decarbonize power.
First process is the power
So
generation.
even the CCS, that's not necessarily steel plant, that's really applicable for power plants too, isn't it? That's the same thing.
That's why our sale is not taking decision. We will not have any more thermal power plant. Only gas-based power plant will be there.
Because that
No,
will reduce-
no new thermal power plant will come under the sale. So this is the one decision.
Drastic.
This is one decision taken. And green power as much as possible you can purchase.
But that's a very bold, drastic decision also, isn't it?
So this decision taken last year by the board.
But again, if the green electricity or green power is available in the future, then I think now people are already working on molten oxide electrolysis process. Just you use that power. I don't know whether that technology will become
Postmortem, that technology has started discussed by
Electrode kind of
become viable.
When the electrode carbon is happening.
And I think that could be.
So maybe that Boston Metal will be very rich company within soon, I hope so, but sorry? Is it? Maybe that indicates that people are looking seriously. So what I would recommend, sorry?
They have discovered a new electrode, I think, carbon.
We should invest in the Boston.
Exactly, not
We
invest.
should purchase.
You develop a technology here because you will be otherwise, hosted by someone, some company. So I think
to develop, otherwise.
what should be local grown, locally developed by local experts like say Professor Shukla and others, work together and develop what the technology.
So in JSL,
Yes,
Carbon based
yeah,
hydrogen.
I think good discussion. This is like
I would like to throw some light on our mission and approach.
yes.
Instead of Government of India showcasing 2070 as net zero, we took a challenge we see it as 2045 initiative, 2050. We have internalized the whole process. It's a brainstorming program called SEED, Sustainable Energy
20?
No, it was scrapped. I mean, 500 megawatt hydrogen plant was there.
Actually, I think JWRE had came to Delhi like in and
Yeah, we acquired land also, but at the moment it's off.
So, thanks a lot. I think that's good to share each other, and that's how we learn probably. But also, where do you get your oxygen from? Your
Oxygen
plant
plant.
on site?
We have our own oxygen plant.
Oxygen plant.
And is it big part of the cost? Pie chart?
No.
No.
Oxygen is when steel making is not a big cost.
Mm.
Anyway, so as okay, renewable energy and hydrogen transition we already discussed a bit. Sustainable other alternatives. I don't know that biomass, biomass. But my problem is that long time I see lots of people talk this reality and practicality and large commercial are yet to be. I think
Far away.
So then waste, recycling, circular economy, etc. So I was talking about that, hydrogen, how green hydrogen is made, transported obviously. So I was thinking that oxygen maybe, if that is a possibility, and then ammonia steel making, another like ammonia blending in the power plants we're discussing. Ammonia steel making, there are research going on also. I think as far as I know. So now let's move into the Australian context a little bit. So we have got, this is South Australia, this is West Australia. So we have got most of our iron ore in the West Australia, like the eastern part of India. And our steel plants in the east coast near Sydney or south kind of South Australia. So that each location has got different kind of scenario. I've got mines, I've got renewable power, maybe thermal power, maybe other power, etc. So they did some calculation. Hot briquetted iron. That's another product, isn't it? Hot briquetted iron. That's a direct reduced kind of DRI. So that's they are saying internationally it is about $554. But if we do in South Australia, we have got good solar and wind, as I said, together. So they might expensive a bit. If we go to Geraldton, I think that's Western Australia, it will be more expensive. But what they say that say $170 per ton, let's put carbon benefit, and then that will drop down. Maybe that will be matching. But that who is going to pay for that? That's the question. And I wish. Do you have some kind of analysis like that in India?
Yeah.
Not yet. So maybe that's another area we can discuss. Then another one, the same sort of hot briquetted iron, SBI, and you can see that Australian dollar. This is all Australian dollar. So again, that we showed that. So this one, flexible green power and inflexible green power. So inflexible means, I think flexible means you, I believe you run certain part of the day when there is electricity, you run it, no electricity, you don't run it kind of that. Whereas inflexible means 124/7 as like a conventional plant. So then you have bigger storage and other kind of infrastructure, capex, etc. The price goes up. So that's our South Australia, Western Australia, Pilbara, Western Australia, Gladstone, I think Queensland, Northern Australia, and Queensland is Western Australia. So various places, this sort of analysis, I think in India, east, west, south, north, each has got uniqueness, right? And different power, different CO2. This sort of work is different. And I'm sure Professor Shukla, I'm sure Leo has a lot of expertise and other groups, other IITs, NIT need to think about that sort of direction.
No, but why Pilbara is so heavy? Is it because of the distance from South Australia to Pilbara?
So why they're different? They're different because they have got different electricity, power.
So once we lay the cables and the power is reached to Pilbara, so the cost is 1 lakh.
Yep. So my feeling is that because they're capturing solar resources varies between countries. That's the thing. So same investment, you get more hydrogen or less hydrogen depending on, because for the Melbourne is a very temperate weather. We have a lot of windy days, whereas Perth is very beautiful weather. Central Australia is super beautiful, but on the other hand, who is going to use the power? So that you need to have a user. So this one is also again that. So I guess this is by component, cost per unit, and you can see that this one is the electricity, I believe, and electricity total. So that's one of the major cost. If you talk about cost per ton of iron basis. And what else you got? Iron ore, hydrogen, water, because water also water should not be big part as far as I understand, but maybe it depends on what are used for hydrogen production one thing and what are used in the steel plant. So that's two kind of water, and then. But you can see that from broadly they are under 1,000-ish kind of plus minus basically. And if you export to the grid, because sometimes, as I said, solar you need to going up and down. Sometimes you need to export and you get some money for that, and that's the income gain for that. So I wish someone have. This is all hypothetical. I doubt there is any plant running, but there is a lot of solar wind plant running around this kind of business, but not necessarily nobody is going to produce iron yet. But it gives the people to understand what's the consequences of that, and I think India is that also required. So this is one of the scenarios. Somebody yesterday said that if I have a steel plant, what is required? So 2.5 million ton of green iron if you produce, what is required? So you require that much solar, that much wind, if that's a combination they want. And in batteries also, this move out and in hydrogen. So basically, grid obviously, grid is finally you have so too many component and too many investment required. But finally, you need to see that and the cost previously I showed this because a lot of capital cost here. Sometimes you feel like the same thing with a house. I mean, if you want to disconnect the home completely from off-grid, you want to go off. Sorry, that's okay. So if you go to off-grid completely, I live in a mountain. I don't have electric power or anything like that. I want just for this kind of thing. But say there is no grid, maybe solar, wind, battery, hydrogen. 4 things will be enough because when there is no solar, like this, maybe if some sun is outside, then I can go with hydrogen. First I need to go to batteries. So solar will charge batteries. Battery will be 100% charged. When there is nothing, battery will kick in. If battery is discharged completely, then hydrogen is there as a backup, as a cylinder, and that will with the fuel cell give the power. So I have got 24/7 power for the year because sometimes battery discharge and still you don't have any power. How do you live? Then hydrogen kicks in, and that's the last resort kind of that way. But obviously your investment is high. But say you are building a new home in Australia, it's a typical home, say $700,000, $800,000 Australian dollar. If I say another $30,000 or another $40,000 you take loan, you never have to pay any electricity bill. People might think about that, isn't it? So that's a long-term decarbonized completely. At the same time, you get some benefit. So this kind of, but again, this sort of scenario, this is optimization. Because one thing, theoretically you can optimize, because ultimately you need certain amount of electrons, certain amount of electricity. Based on that, we are back calculated, and that could be 50-50 ratio, that could be 80-20, that could be whatever ratio, depending on you want to minimize the cost also. So these equipments you need to have, and third thing also, sometimes what we do, because we have got what is called Center for Hybrid System, CHASE, in our lab. So all these equipments are there, and we connect them, and we run them for 1 year, 2 year. Actually, I'm running nearly 2 year data. A lot of people talk a lot of things, but the data, this is a small system, not as big as this, but ultimately it doesn't matter, big or small, as long as you have sensors, you have lots of data, you can analyze it, you can make decisions. Okay, any question or comment? Yes? Please go ahead.
Sorry for my ignorance.
Yeah, sure.
I was not informed about the methane impact on net zero.
Methane emission. Yeah, that's getting a critical
You
list.
said something like 100 years, 50 years, 500 years.
Yes, sir. That is the question. I also just.
Very little elaborate.
Okay?
You want
Okay,
I also want to understand.
so methane emission.
Yeah,
So natural gas industry, there are 2 types of kind of gas generally. So one is normal gas and coal seam gas. I'm not sure, hopefully that's okay. So is it on? Okay. So the natural gas, some gas like in US maybe, they call it fugitive emission, that one, that leak. So leak can happen during the gas extraction, leak can happen during the transmission, and even at point of use. So because methane, at the moment we are doing decarbonization, lot of CO2 focused, point source we can control CO2. But because methane is all around, and even a small amount of leak will make, because it is 25 times or 28 times more potent than CO2 on 100-year time frame, for example. Actually, 20-year time frame will be more potent. So global warming potential is high. So globally, they are working on, actually, luckily Australian gas is very low leakage. So we have got, in the gas field area, we have got sensors. from coal-based to gas-based system as a transition. Unless we manage that risk, then maybe methane will be even another contributor for global contribution. Does that make sense? Does that answer your question? Kind of? Yeah. So in US, sometimes there's up to 5% leakage happens, and particularly some of the gas field is more leakage than others. So it's a, I don't know what.
Is that the leakage is going to have higher impact on global warming?
More potential than CO2. Yes, 25 times or 28 times, I think they said 28 times more. So in India has got own gas, right? In gas fields.
Yes,
Yes. So that's one thing. Another fugitive, that's called fugitive emission essentially. But also flaring that can, because you can methane. But methane, when you burn methane in a flaring situation, then that's natural gas you're burning, right? Ideally, if it is good flaring, you should probably make CO2, lots of CO2. But sometimes that is incomplete, and you get some methane out at the same time. So that's another problem. So these are kind of 2-3 areas where methane should be targeted. Does that answer the question?
So there is a governance which has been designed until 2070, the methane emissions will not be there.
Yeah, so that's the, because that's the reason. Because after CO2, methane will be another area people will be looking at more seriously. So that's why, in the plant, wherever it is used, transported, make sure that no leakage, less leakage, etc. That's how it is. So now you got it, right? So see that 25 ton per hour, that means if you multiply by 8,000 hour, you will get the significant hydrogen, looks like with a 6 ton of storage. And that gives us 2.5 million ton. So one blast furnace, right? Roughly. Equivalent to one blast furnace. So that's again, Pilbara, and Gladstone is Queensland. So this is West Australia, this is Queensland. And it's a green iron, green gas farming of power, as reductant. So that's ton of CO2 per hot briquetted iron. So you can see that very low to kind of high, and then with the carbon price, you can potentially reduce that, and the same way, so that some places you get more reduction, some places less reduction, and inflexible means that it's constantly running renewables plus gas.
Pilbara is in Australia.
Pilbara is the main Western Australia, main iron ore, like your, what I would say, comparable. Why is the major iron ore source here? Chhattisgarh or Odisha? Yeah, it's like Odisha, Australia.
And Gladstone is not rich in iron ore.
Gladstone, no iron ore at all. It's more renewables and LNG and other kind of facilities there. Actually, Gladstone port, Adani port was development was in Gladstone. So now that's another one. If you look at the, so that's the price, but $1 per ton of iron, I believe. And that is different countries, so that's like long-term 5-year average, it's like about nearly $800, but it goes up and down on various countries. India is there or not? Maybe not.
This is the price of what?
I think it's price of iron, price of steel, price of steel. But if India would be very cheap, right? I think the bottom line would be India, right? Because India is relatively cheap, what we are suggesting. So often, so why I'm showing this, reason I'm showing this often.
We are comparing the steel costs of all the countries.
Yes, various countries, but the reason I'm showing that majority of the exercise people take a spot price. Oh, this is the price, so we need to evaluate that. But you see, if you say 5-year average, it goes up and down, but you need to have a long-term average price for this to calculate.
It's Australia.
Australia.
This is cheaper. It is as cheaper as India. 43,000. In Indian currency, it's 43,000.
It will convert in dollar, right?
Yeah, that is Australian dollar.
ऑस्ट्रेलियन डॉलर तो सस्ता रहता है अपने तरफ
52 rupees.
And this is, I think, cost of iron, again, cost of iron. So it's not steel, I believe. So blast furnace, $400. So that's two components that they are talking about. I think that including carbon, excluding carbon, that kind of scenario, I believe. So that's going like that. International, so before Australian hot briquetted iron. Then again, South Australia, Queensland, and Western Australia. International peak iron, so that's the number. Guyana is our kind of again south of What is Australian iron
Iron
ore
ore.
prices?
These are the iron ore prices.
No, this is iron production, produce iron. Iron ore price is
Big
$100.
iron.
Big iron.
$100 plus.
Big iron.
Big iron, but HBI not big iron. HBI next stage, I guess, right? So whereas iron ore is about plus minus $100. And the other point is that some of the technologies we often complain, say hydrogen technology is very expensive now. It is expensive to be honest, at least 5 times more. But you look at solar, how that came down, and it is dropped down 20%, and yes, it was $100 to as capacity increase, you get quite cheap now. I think it is that what is the solar cost here?
This is a global figure.
This is on an average global. So what is called
Global or Australia?
Sorry, Australia.
Global or Australia?
It's global. It's global situation.
5 CR right now.
Yeah.
That means 50 million Indian rupees. 1 million Australian dollar
1 million per megawatt.
per megawatt.
1 million per megawatt. So I think Australia is similar, maybe a little bit less. Some of it depends on how big and how small. So that's another point I'm saying that if you want to cost a technology, you need to consider the learning rate, for learning rate, adoption rate, etc. And this varies between technology, obviously. Not say hydrogen technology might not follow that route, but we cannot rule out any technology just based on the cost. That's the point I'm making, because I'm towards the end of the discussion. So if you look at renewables, we are talking about this as a solution, but what's the solution? So Australia sees 26% solar. So if you have 1 megawatt, you get 200, isn't it 200 kilowatt? 200 kilowatt system kind of, right? If you compare with coal-fired power station. So China, India is 18% looks like. So seasonality also Australia little bit low to moderate. Indian seasonality high like say monsoon, etc. Japan is low, solar anyway. South Korea, Germany, and then wind. So Australian wind actually shows less high. Australian wind, my understanding is 40 to 44. So, but it depends again. I mean, South Australia we have got high, usually 44%. Because all these things, nature give whatever gives, we don't have control. It's a kind of. So but Australia is lucky, high solar factor, high wind factor. So if you don't have that one, if you have more investment and you don't get enough power, obviously that will be expensive. It's a simple formula.
What is multi-TW?
Sorry?
Multi-TW.
Multi.
What is TW?
So China, I don't know what multi-terawatt or I'm not sure. I don't know.
Terawatt.
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 Because China has got.
What is the meaning of terawatt here?
TW, what does it signify?
To be honest, I don't know. The reason is that, so my feeling, China has got very high wind penetration. You know, global wind, overall, 80% probably China has deployed. It's a huge amount. Maybe even whole, they have got a huge amount, and that's why they produce green hydrogen at cost cheaper because they have got additional electricity. And those electricity, that wind facilities they have built, they are not tied with any use. So it's a kind of additional. So maybe they want to get the hydrogen market. That's another. So but you can the point is that there are varieties of factors you need to take into account, and each country has their own advantage and disadvantage. But I'm surprised even China has got relatively low wind, I would say, but still they have invested heavily on wind technology. Maybe they also in turbine technology, Chinese company Vision is very well.
It is, I think, the capacity factor. The wind, how much electricity wind will generate. This is percentage is that.
This 25% of the time of the day or total average of the year, you will get 25%.
25% capacity factor.
That's what is called capacity.
If you install 1 megawatt, you give
250 kilowatt.
250 kilowatt.
So,
That is a capacity factor.
so that's the thing. So say 1 million per megawatt. What is the coal-fired power plant? Similar or less?
1 million per megawatt.
Coal is much cheaper, isn't it? Should be cheaper.
Please repeat.
What is the question is that $1 million for 1 megawatt solar plant. If it is coal-fired power plant, what's that
It
number?
is approximately like for 1 megawatt is 10 crores. 10 crores.
$2
Approximately
million.
10 to
$2
12
million.
crores. So
2 million.
2 million.
So coal-fired power plant will be 2 million.
2
It
million.
is double of solar.
Yes.
But if you compare, it's not people do not appreciate that. 1 megawatt solar means
1 megawatt electricity will be there.
no.
18%.
Now that 1 megawatt
So that's
capacity.
18%.
18% of 1 megawatt. So
Yes.
basically, if you have a build a coal-fired power plant 1 megawatt, you will get 1 megawatt power.
Yes.
Whereas solar, you will get 0.9, 200 kilowatts. So if you say invest 1 million, you should multiply by 5.
5.
So 5 million. So 5 million compared to 2 million. So that means double capex, but solar you don't have any opex.
Running cost is not there.
Nothing there almost. Maintenance maybe 5% or something. Whereas solar or coal, you need to have a
Longer than
minimum.
one.
So 1 megawatt, how much coal required?
For 1 megawatt,
Yeah.
Yearly cost.
approximately like
500 megawatt with
4,000 tons.
4,000 ton per year. 3,000 ton
For
per year.
1,000 megawatt, it is like 40 lakh tons.
3,000 ton per year or something like that.
4,000.
Because 1 gigawatt power plant, 3 million tons, that's what I say. So 3,000 tons, say 3,000 ton, $100 per ton, right? So that much amount every year just for fuel, right? Your per coal, your per others.
3 million tons for 1 gigawatt.
Yes.
1 gigawatt coal plant, roughly, that's the rule of thumb.
That's why
Depends on coal
3,000
quality.
for 1 megawatt.
Depends on coal quality also. So I think, so I should finish it, I'm just conscious of time. So a 2070 net zero target, decarbonization process in India is unlikely to be an early destination for, it's a kind of Australian innovation and being the second largest steel producer. So they said will help green iron compete with carbon intensive iron in the near term, but until India's government prioritizes less emission intensive growth, India is very unlikely to be a long term destination market for green iron. I think that's somebody assessed. You think?
All are agreed. All of us agree.
So even we have a roadmap to 70, 0, etc., etc., it will be challenged. It will be challenged. And for that one, everybody has to probably work together, government, industry, university, and international situation is there. Global issues. Any question? I think that's what we discussed. Evolving strategies, everyone is doing that. Standard target, at least your star rating is there. Significant challenges and connectivity issue. Yeah, I think these are the kind of things about on your roadmap, so that scrap, production with accuracy, quantifying, etc., branding. Yeah, that's I just giving that. Yeah, ultimately my dream is to see that somebody makes, it is still in the air, that use the biomass. That was the dream I say. I was a big biomass work we had mostly grows and trees and you manufacture with zero emission. But it's a kind of dream.
Stars that grows on tree.
Any
Bullet
question? Comment? Yeah, I think dreams sometimes become real. Sometimes they don't come to reality.
I think the company Mirai car has done this. I think your dream has been